I'm CK. Tonight we're going to do what I think is going to be a quick one. It's a Patching Panda Copycat. It's a 2-channel multi, so it takes voltage input, multiplies it across a number of outputs. This one has 2 channels, so you can do 1 to 3, 2 to 3, or if you don't put something plugged into 2, 1 will go to all 6. Just a nice, it's buffered voltage transmitter. It's not precision, but I don't really care about that. And of course, in the spirit of it being a copycat, I apparently bought 2 of them, so I'm doing a copycat. Hope you enjoyed the video. So here's the bag, and again, it's from Patching Panda out of Barcelona. Nice info link. I have exchanged emails with them in the past. They're very responsive. Let's see what's in the panel and circuit board bag. It's a little piece of paper, some tape, or to quote somebody else, some sticky tape. Okay. I was wondering, I didn't see many components. And then they say go to patchingpanda.com for build instructions. As you can see, it's very small. Let's put less than a ½ inch in width, 3/8 of an inch in width. And as you'll notice on the circuit board, put my visor on, it does have surface mount components already installed. So there's one TI chip there, same TI chip there, they're TL074Cs, op amps, 2 capacitors, resistors, capacitors, resistors, 1 diode there, 1 diode there, and same thing, capacitors and resistors. And so yeah, this is going to be, all we're going to be doing is putting the connectors and the LEDs and the power connector on this one. So yeah, it'll be a pretty quick build. Let's get a parts tray out. First we have a black Patching Panda sticker. I gotta go look on my sticker wall. No, my other Patching Panda is white, so now I've got one of each to put up on my sticker wall. That's nice. I always get black-faced units primarily because I always get silver-faced units dirty. There's some pin headers. Eurorack power supply, even though I can't imagine this draws much power. I'll look that up. Then basically all we've got here is two LEDs and the jacks. One thing that you'll note here, which I appreciate, the panel nuts are not on the jack, so you don't have to take them off yourself. So if you're really lazy like me, you don't have to do anything. Let me go ahead and get the soldering iron heated up and pull up the build guide, and we'll have at it. Again, this is going to be a pretty straightforward build. The only challenging part about it is cutting up and mounting the pin headers, connecting the jack panel to the data panel, and again the circuitry is pretty straightforward. Voltage goes in, and I somehow, and I don't know how they're doing it, they're sending it to the various input pins, and there are, in each one of these 74OCs in this package, there are 4 inputs and 4 outputs. I think that they're just, and I'm looking, yeah, they're just connecting all the inputs together. So all the inputs get 1 voltage in, and the outputs obviously repeat that and send it out the back end. So it's not very, as they say, they're not saying it's precision, but it works just fine. The hardest part of this is going to be putting the pin headers on, because there are, and they do have a build guide. It's very short, as it should be, but then again, it's got lots of pictures, and pictures are always great. So they did a great job on the build guide, even though it is very brief. So we've got 4, 2, and 2. So we're going to be building this way with the capacitors facing the jack board, and with the female pin headers on the circuitry board. And we'll pull this all apart. And again, these are not the rectangular pin headers that you may be familiar with. These are round pin headers. So, got 4 down here, 4 down here, so we'll get our pliers. One thing about these pin headers is they are not going to lose pins when you cut them. The rectangular ones tend to lose pins. You lose 1 pin for each cut you make, or at least I do. I'm sure there's somebody more competent than I who can save all the pins in a rectangular pin header. I can't. So, as usual, we put 1 leg on, then we look at it from the side and heat that pin up a little bit and make sure it's absolutely perpendicular. And it's not absolutely perpendicular because, as usual, I burnt my finger and I flinched. Now it's perpendicular. It wouldn't be me if I didn't burn my finger attaching pin headers. I'm not going to solder the rest of the pins right yet. I'm going to do the pin headers on the jack board first. Make sure everything goes together right. I didn't do my typical commentary on the board. The boards are good quality, through-hole plating. And as you can see, the non-plated portions resist solder very well. Okay, so that's all the pin headers, and I'm going to gently, not fully, but gently, wow, that one's, these holes are a little big, I guess, because this pin header seems almost twisted. Yeah, the holes are a little big. Interesting. So I'm going to mate the pin headers and then solder everything, because I want to make sure all the pins mate properly. Wow, those went in way too smoothly. It's like they don't have much friction. Huh. I hope they make good contact, because I don't know if you can see that I'm barely touching it and the pin header's sliding in and out. I have not seated them fully, so they probably hold together pretty well when they're done, but I'm surprised that they're as loose as they are. Rectangular pin headers are not. So now that we've got them mated, so we know they fit, we'll solder all the pins. Okay, so the top camera is on, so I'll go back and do a top view of a couple of the things I said. The pins are not real tight or real snug in the pin headers, so I'm hoping, as you can see, so you got that from the side before, now you can see it from the top. But that board's also, those pin headers are all soldered. We'll flip it over and do the other side. And what I was going to say before is, yeah, it's going to take more than the 12.5 minutes because of these pin headers. And you could tell on the timer that I bought to time all these builds that I always forget to turn on. So it doesn't help us at all. Pin headers are on. This board, the component board, gets the power connector. And this is not, as you can see, this is not a keyed socket. So you, Mr. and Ms. Eurorack, are going to need to pay very close attention to where the 12-volt red stripes, negative 12-volt red stripe side is, because the board is not going to help, the socket is not going to be keyed to prevent you from doing it wrong. So if something goes wrong with when you're first powering this up and testing it, first thing to check is, did I hook the Eurorack cable up correctly? There's the power jack, or power connector. All that looks good. Double checking all the solder joints. All looks good. Now we can do the jack board. So it's just a bunch of jacks and the LEDs, and of course you want the LEDs to poke through the panel correctly. And he does mention this, that he shares ground pins on some of these sockets. Okay, I'm going to solder all the jacks on now after I put the panel on to make sure they're all aligned. All aligned and all flat and flush. And now I'll just solder them all, and then I will do the LEDs, but I want to get the jacks all in first. And we'll speed through that too. So all the jacks are in, and the connections all look good. We'll pull the panel back off and get our LEDs and make sure we get our polarity right. This is very strange. Let me go grab a demonstrator. I'll be back in a second. So on a typical LED, you have the long leg is positive, the short leg is negative, and another confirmation, and this is where you can't see, but you probably know better as well as I do, that the negative side is also where the LED is flattened, like so. Now on these LEDs, it's got a short leg and a long leg, short leg and a long leg, but the long leg has the flat side, not the short leg. That's very strange. And now it's making me question which lead is the cathode and which leads the anode. That's not good. So I'm gonna use our meter and do continuity. Set your meter to continuity and touch the leads with the meter probes, which is a bit of a pain because I don't want to spread these out because I'm going to use this LED in something else in the future. See, as you can see, when you've got the negative lead of your meter hooked up to the negative leg and the positive, you touch it to the positive probe, it turns the LED on. If you do it the other way, it does not. So if you're ever in doubt about the polarity of an LED, you can do that. So that's what I'm going to do here. I'm going to make the assumption that the short leg is negative. And I'm right. Okay, good. The short leg is still negative. It just happens these LEDs are, in my opinion, very bizarre and have a flat side on the positive side. That's just weird. And we can put the leads through the holes. Now I'm going to put the front panel on again. And this time I'm going to tighten a couple of the panel screws. Now that I've got all the panel screws on, panel nuts on, for crying out loud, we're going to push the LEDs forward through the front panel as far as I'll go. One goes all the way. This one doesn't go quite all the way, so let's give it a little bit of encouragement. Now these, I'll set it down like so they don't slide backwards. Now mate the boards. And push them together tightly. Again, I'm not a big fan of the tension on these pin headers. They're a little loose, and there is no way. Well, actually, it's interesting. And as you can see, there's space to put, there's holes drilled to drop a screw through there to keep the boards attached, but he does not include one and he doesn't show it in the guide. But I really want to attach those, and I don't know, the jacks seem like they're going to interfere. Let me see if I can get the nut between those jacks. No, that won't go through there. I'll admit, I'm not real pleased about that, because he should have included some fasteners that work in there again, because these pin headers are not really all that secure. Again, this is bugging me. This is going to fall apart. I feel like it's going to fall apart. It's probably not going to fall apart. but I feel like it. So what I'm going to do is just take some solid core wire, take the insulation off it because I don't care about that, even though I guess you could keep it on. It wouldn't hurt anything to keep it on. In fact, it might even be better, but I don't feel like it. I want the insulation off, and I'm going to secure it with a little piece of wire and a pigtail on the back, because it is bugging me. I'm sorry, it's just the pin headers aren't tight and I don't have the right fasteners to fix the two boards, and that's not good. And again, as I've said a number of times, I don't take these things on the road, they just live in my studio, so vibration is not a big deal. But if you were building this to put it in a club rack or a touring gig rack, I strongly encourage you to do something to connect. Use these two holes that are already present in the circuit boards to secure the front panel to the back panel. You don't want to go excessively strong, you just want to have so it doesn't wiggle. And trim the ends of the pigtails off, and because I'm more paranoid than most people are, I'm going to put a dollop of solder on the end of those pigtails just to make sure they don't come loose. Now we're all done. All good, and that's it. That's the unit. It's very thin. I'm hoping that wire that I just put in there doesn't foul rack unit I put next to it, but we'll figure that out. We'll cross that bridge when we come to it. So that's it. In, 3 outs for this in, 3 outs for this in. If you don't have something plugged into this one, this input is repeated on all 3 outputs. So that's the story. Next, I'll go ahead and put it in the rack and we'll show it in action, even though there's not much action. We'll look at it on the meter. Let's see how it works. Typical setup, I'm using the MIDI keyboard, feeding a Befaco MIDI thing to a Befaco ADSR to an ADX Systems VCO to a Danny Sound envelope generator VCA, VCA, and then to the multi we now have. So let's close in a little bit more on the multi and the meter, because really it's all about the meter. Right now it's still holding the voltage from the last note. The MIDI thing is still sending 1.9 volts from the last note I triggered. So if I change the octave, go up an octave, up to 2.9, go up another octave, 3.9. Now that's normal, that's what you would expect, but the interesting thing and the reason why you have one of these is because that voltage is coming from the MIDI thing into here. That's the control voltage for the note, and it's coming out here to the meter, and it's also coming out, the same voltage is coming out here to the VCO. Why is that important? You know why that's important probably, but it's so if I want to send the same note CV to a different oscillator, I just plug it in there and I'd be talking to both oscillators. If I had that one plugged in, I don't. But the point is that voltage going in here comes out duplicated on those 3 jacks. Now, since I don't have anything plugged into the number 2 input, that means it's also being repeated. So as you can see, I'm still coming into input number 1, and I'm at the bottom. There's input number 2, and I'm actually all the way at the bottom. And I'm getting the voltage repeated all the way there. So obviously it works for CV, and it works for, let me put an envelope in there. I don't know how well you're going to be able to see this, because I don't know how fast the transient's going to be. I'm going to turn the oscillator down because the interesting sound you're hearing is the envelope being acted on as if it was CV. But you can see, again, the ADSR envelope is coming out of the Befaco module going into input 1. And as I trigger the envelope, you can see the voltages change. It's in falling off now, it's in sustain now, then it'll be in release. So obviously, I'm sure you can think of a lot of ways that you can use the same envelope going multiple places, and instead of simply doing that with a splitter, which can cause you electrical problems down the road, this, taking your input, putting it through an op amp, and spitting it out 3 different ways, is pretty good, pretty useful. And these are really inexpensive. In fact, as I was thinking about this after I put it together, if you wanted to think about designing your own eurorack module, and you had some ideas for the future, but you wanted to get started, this would probably be a type of thing that you could build and build your confidence in it, because again, it's just an input, power coming in, conditioning the power a little bit with the capacitors and diodes, then feeding it power into the op amp, and the op amp taking the signal and putting it out. Lots of great places online to learn about how op amps work. But you could do this and lay out a simple circuit board. It's a relatively straightforward build, and you know, the Patching Panda folks haven't done any black magic here. There's no programmed microcontrollers or anything. It's simply connecting this signal into the inputs on the op amp and taking the output and putting it out the output jacks. So if you wanted to get into making eurorack modules, think of how you design this one and lay it out in a PCB program or in Spice or wherever you want to do that, and get a feel for it. And also, buy these, buy a couple of these. Now that you've seen it, you probably know you need it, and they're inexpensive. I forget exactly how much I paid for these, but one of the reasons why I bought 2 was because they were so inexpensive. So that's the Copycat from Patching Panda out of Barcelona. Hope you enjoyed the video.